Section 7.5 is all about polynomials. So by the end of this lesson, you'll be able to classify polynomials and write them in standard form, as well as evaluate polynomial expressions. So first, we have just some definitions, some vocab terms. A monomial, it's an algebraic expression that's either a constant or a variable or a product of a constant and one or more variables. So there will be no addition or subtraction signs in a monomial. It's all multiplication. We find the degree of a monomial by adding the exponents of all of the variables in that monomial. Essentially, a monomial is what we've referred to always as a term. So again, the degree is found by adding the exponents of the variables. So let's look at some examples where I want you to find the degree of each monomial. You're just adding exponents on variables. So for number 1, we have 2/5 x. You may not see an exponent here, but remember when it's not written, it's an implied 1. So the degree here is 1. For number 2, you are adding the exponents. So we have x squared and y cubed. 2 plus 3 is 5. For number 3, we have 5xy squared. And again, remember there is an x to the first. So when you add 1 plus 2, you get 3. And finally, for number 4, we have negative 8a squared b squared. So add 2 2's to get a degree of 4. Some more definitions. We have a polynomial, which is can be just a monomial or the sum or difference of 2 or more monomials. Essentially, it's a string of monomials added or subtracted. So a polynomial now consists of several monomials being added together or subtracted from one another. Standard form of a polynomial, or a polynomial is in standard form when the degrees of its monomial terms are decreasing from left to right. And the degree of a polynomial, and this one's important, this is very different than the degree of a monomial, but the degree of a polynomial is found by looking for the term or the monomial that has the greatest exponent. So you're looking for the term with the greatest exponent, and then that is the degree of the polynomial. Please make sure again that you do have these definitions in your notes. And now we have some names that we need to remember, but when a polynomial has a degree of 0, it's a constant, and it's just a number. When it has a degree of 1, we call that linear. When it has a degree of 2, we call that quadratic. A degree of 3 is cubic. A degree of 4 is quartic. A degree of 5 is quintic. And anything that's 6 or more is just that number to the degree. So 6th degree, 7th degree, 8th degree, and so on. I want to make sure that you have this chart in your notes, please, because you will need that working through the worksheet. So here I just want you to find the degree of each polynomial. Remember, the degree of the polynomial matches the term that has the highest degree itself. So that 4x is 4x to the first. This term has a degree of 1, and the second term, the minus or negative 18x to the fifth, has a degree of 5. So the degree of the entire polynomial is 5. It matches the highest termed degree. For number 6, again, just find the degree of each piece, and then the one with the highest degree, that's the answer. So here we have 3 because it's 2 plus 1. Here we have 2, which is 1 plus 1, and a constant has a degree of 0. So this polynomial has a degree of 3. For number 7, we have 4, 2, 1, and 0. So this polynomial has a degree of 4. Finally, for number 8, we have 5, 5, 4, and 0. This polynomial would also have degree 5. Now, if we were to name these based on the degree, this would be quintic, cubic, quartic, and again, quintic. So make sure you're getting yourself familiar with these terms. Now let's look at how to classify a polynomial based on the number of terms it has. And this is a little bit easier because some of these prefixes on these words you understand. So if a polynomial just has one term, we call it a monomial. And some of you know that mono just means one. A binomial then has two terms. So there will be one addition or subtraction sign separating the two terms. Most of you know that bi means two. For example, a bicycle has two wheels. Finally, if there are three terms, we have a trinomial. Think about a tricycle having three wheels. And any polynomial that has four or more terms, we just refer to it as a polynomial, and poly means many. So some of you know those prefixes, I would assume. Also make sure that you have this chart written into your notes because you will use it as well when you are working So the next several examples, you are writing the polynomial in standard form, and that's in order decreasing exponents. We're classifying the polynomial based on the degree, and we're classifying it based on the number of terms. So when you write a polynomial in standard form, again, the exponents need to decrease from left to right. So the highest termed monomial is what's going first. The highest degree monomial part is what's written first. So this is a 2, this is a 0, and this is a 4 based on the degree of each monomial or each piece of the polynomial. So when I write this in order, it's negative 9x to the 4th. Remember that minus sign means the 9's negative, plus 6x squared plus 7. That is standard form from left to right. Our exponents or the degrees are decreasing. Now, what is the degree of that polynomial? Well, the highest one is a 4, so the degree is 4, but we need to write that using the term that we described, and that's quartic. And then how many terms does this have? Terms are separated by addition and subtraction signs, so we have 1, 2, 3, so this is a trinomial. So example 9 is a quartic trinomial. Number 10, write each polynomial again in standard form, classify it based on degree and number of terms. So if we write the degree of each monomial within the polynomial, we have a y to the first, so a 1, a 0, constants are 0, and a 3 because it's cubed. So if we write that in standard form, it's negative y cubed plus 3y minus 4. Again, that's decreasing order from left to right. The degree then of the polynomial is 3 because that's the highest. So this would be a cubic trinomial again because there are 3 terms. Okay, here's one that's a little messy. We have 3x squared minus 2x plus 1 plus x squared minus 2x plus 3. Before you can put something in standard form, you need to combine all of the like terms. We have several like terms here. We have the x squareds, we have x's, and then we have the constants. So however you want to go about rearranging those, 3x squared plus x squared, and I like to do them in order that I know I'm going to write them in standard form. I know the squareds will come first, so that's 4x squared. You have a minus 2x and another minus 2x, that's minus 4x, and a plus 1 and a plus 3, that's plus 4. We did some simplifying of expressions way back in the beginning of the year, so hopefully this is a review for you. So now the degree is a 2, and that's quadratic. Remember, it matches that first term or the highest, and again, 3 terms, so it's a trinomial. So we're combining like terms, we're putting exponents in order from greatest to least, we're classifying it based on degree and based on number of terms. Why don't you go ahead and pause the video and try this one on your own. So you're combining all of the like terms and classifying it. Once you're finished, then resume the video and check your answer with me. So we have a 6x cubed and nothing to combine with that. And that goes first because as I look across, I can see that 3 is my highest exponent. Now we have 3x squared and x squared. So when I combine 3x squared plus x squared, I get 4x squared. Be very careful here. This is a little bit different from what we were doing in the beginning of this chapter. You are not adding those exponents together because we are just combining like terms. When we combine like terms, we don't do anything to the exponents. Then we have a 6x term, so plus 6x, and we have a minus 5, so we're subtracting 5 in the back. So here we have a degree of 3, so it's cubed. But now we have 4 terms, and so a polynomial with 4 terms is just a polynomial. We don't have a fancy name for that. So we were able to classify polynomials and write them in standard form, and also evaluate some polynomial expressions, which is what we did when we were combining the like terms. We'll be working on the next worksheet in class, worksheet 7.5.